Here in this case we are going to project an object from a height h, and if it is projected at an angle theta with the horizontal. Suppose you are throwing at an angle. So far we have been looking at a case where from a height h you are projecting horizontally. Now from a height h you are projecting at an angle theta with respect to the horizontal. Suppose this is a horizontal direction and you are projecting at an angle theta to the horizontal. If this angle is theta, this projectile's velocity can be resolved into two components. If this is u, as usual, we know this will be u cos theta in the horizontal direction. This will be u sin theta in the vertical direction. You know, the path of the projectile will be like this. It will come and fall down. So we are going to find out what is its velocity after t seconds. When you project it with velocity u, its initial horizontal velocity is u cos theta, vertical velocity is u sin theta. In the previous case, it had no vertical velocity. Now you have got a vertical velocity at an angle theta, so that it is u sin theta. So initially it had some vertical velocity. You know that throughout the motion the horizontal velocity will not change, but the vertical velocity is influenced by gravity, because gravity is acting in the downward direction, whose velocity is g. So because it is g, the vertical motion is an accelerated motion. Hence the velocity in the vertical direction at any instant is initial vertical velocity plus acceleration in the vertical direction into t. So the vertical velocity at any instant equal to uy, which is u sin theta upwards, plus ay is g downwards into t. So velocity in the vertical direction at any instant is u sin theta. If you consider u sin theta positive, g downwards, which is negative, minus gt. So after a while, if the projectile is here or somewhere, its velocity has got two components. One is horizontal velocity, which will be equal to this velocity u cos theta, the vertical velocity as dictated by this relation u sin theta minus gt. So it is Vx, which is u cos theta. This is Vy, which is u sin theta minus gt, u sin theta minus gt. So the net velocity will be the vector sum of these two velocities. So this is u cos theta and u sin theta. So as we did in the previous case, v vector is x component of the vector plus y component of the vector. So Vx is u cos theta in the right hand direction, or we usually take it as x direction, which is the unit vector along the x axis is I cap. This is downward direction, so it is u sin theta. So I will write it here. So instead of this halfway writing it here and there, I will write it here. So the net velocity is Vx plus Vy, and this can further be written as Vx is u cos theta in this direction, hence it is I cap, plus Vy is u sin theta minus gt in the downward direction, so it is minus j cap. So V vector is u cos theta I cap minus u sin theta minus gt into j cap. So the other things are very specific to the problem. So what they give in the problem and what you are supposed to find out, that you decide. But here, this is how this kind of problem has to be approached.